Okay, let's make this a little bit better, okay? Because yeah, we managed to teach you how to draw a square. It's not very. Um, I mean, this just doesn't scale, right? I mean, this is a lot of steps to be able to draw a square. But the beautiful thing is that you can, for example, put this in loops. Okay, so let's see how that might look. Um, we're going to grab one of these control statements, okay? And in fact, I'm going to grab two of them. I'm going to take when the green flag is clicked, that's up here, okay? So now instead of actually double clicking on this to get it to run, I can just say, just click on this button and it'll make it do something, okay? Um, the other thing that I want is this repeat command, okay? And the repeat command lets me say, do something 4 times. Now, if you look at this seems to be happening. It's the same set of commands. Um, I just do them 4 times because I have 4 sides to the square. So let's just grab those, okay? So I can do that. And now what I'm doing is I'm breaking up my program. I just dragged it away from here. And now this move command can go inside of the repeat. Okay, that grabbed all those 3 lines because those were still together. So what we're saying is, I want you to do the following 4 times. Move 100 steps and then turn 90 degrees and then wait for 1 second. All right, that's going to draw a square. But remember, we like the idea of clearing the screen first and making sure the pen is down. So I'll make sure that all of these are together. Okay. And this will happen when I click the screen. I can still leave this here. It's actually not hurting anything, although now it's no longer really part of our program. So let's click this. We've cleared it. The pen is down. We're moving. Sure enough, that is a rectangle. Okay. So let's make that a little nicer. Okay. Or rather, let's take advantage of the fact that I have a repeat. I don't want to do this 4 times. I want to do this 3 times. Okay. And now I don't want to turn by 90 degrees. I want to turn by 120. And let's see what that does. Of course, it's going to draw an equilateral triangle. Nice. How about 5 times? Okay. And you see that now I can experiment with this. So if I run this, oops, I'm sorry. If I run this, actually, you can't really tell that I did anything interesting, just because I'm drawing over the same section that I was drawing before. But here's something that might be interesting. Instead of 120, let's say we go 117 degrees. Okay. All right, let's see what that does. Ooh, this is no longer an equilateral. Oh, interesting. Okay. Now, geesh, why do it 5 times? Let's do it 20 times. Okay, I'm going to make this not wait for a second. Let's wait for 0.1 seconds. Okay, go. Aha, it's looking like a spirograph pattern. I'm going to be brave. I'm going to do that for 200 times. Okay, now one of the things that I want to say about this is that this is really a lot of fun, right? I mean, spirographs are cool. The danger here is that when students discover that they can do this, and I've actually seen students discover this without discovering loops, they just click the run this another time, run this another time, run this another time. And it is such a sense of accomplishment to be able to produce this that it is frankly unbeatable, okay? They're hooked and they'll generate 10, 20, 30 of these pictures and absolutely love it. Now, this is a quandary for us as educators, okay? Because on the one hand, we don't want to tell them, stop doing that, you're doing it wrong. On the other hand, they are doing it wrong. So how do we manage this? The reason that I want to manage this kind of impulse is that I want them to have fun. I want them to experiment. So by all means, go ahead and draw random spirograph patterns. I mean, it's unavoidable, okay? And it's fun, so why not do it? But I also want them to learn something. And there is no learning happening when you draw this shape. For instance, I really had no clue that that's what he was going to do. Now, if I'm driven by kind of direction, okay, 120 was correct, 117 did this, what does 123 do? Let's look. Oh, that looks very similar. Interesting. So maybe the sign doesn't matter, okay? Okay. What if we go really different, like say 130? Okay. Now I'm actually doing some strategic differences, okay? And perhaps that will show a different pattern. Perhaps that will give me something to try to use as kind of an example, okay? This one is interesting. Notice that it's not filling in as much as the previous ones. Huh, why is that? Well, I don't know, right? So maybe it's worth exploring. Sometimes it seems like they fill in. Sometimes it seems like they don't. Maybe I didn't go enough times. Let's try 500 and see if that makes a difference. Okay, so yeah, some learning can take place simply because of this, right? But only if it's directed, only if it has a thinking component that says why did this happen differently than the previous one. So when you see your students kind of at this stage, and believe me, if you use this programming language, you will see them at this stage. Then try to guide them towards these types of explorations. You can even be more goal directed, such as how could we possibly get, say, 10 corners instead of 50? And that can at least lead towards some discussion of factors, right? Common factors and so on that might be fruitful as studying mathematics. And then I feel a lot better about it. Okay, so yeah, this is cool. Have fun. Uh, if you don't guide them at this stage, the learning will disappear. But if you guide them, it can actually be very, very fruitful. Okay. All right. So what have we seen? We have seen how to do some simple instructions that will move the sprite and the pen. We have seen how to do some simple loops like repeat. We have seen uh, managing the pen movement. Let's see what else there is. Okay. So here is looks. Okay, you can build costumes, and we don't have any other costumes here, but you could actually go ahead and create one. So, for example, I bring up the paint application here, and there's my costume. Okay, you can always do better than I do. And quite frankly, you should be able to better than I do. So this costume is quite large. Okay, for the turtle. And by the way, it is a costume just like any other. So, for example, I can move by 100 steps, and you saw that it did. Okay. Now I can no longer actually see which direction it's going because my costume is not a very good one. I can change the costume back. I can leave it here. And in fact, in looks, I can actually ask it to switch to a costume. So I want it to be the turtle again. Switch to that. I want it to be the scribble and switch to that. Okay. You can say hello. Okay. So I'm going to move it back to the center. There we go. This is just a way to put up a message. You can think for a period of time. That's just a bubbles. There's different things. You can change effects. You can change the size. Actually, this is useful, particularly you notice how the costume that I built was really too large. You can say I want it to be at 50%. Okay, that one changed. And if I switch to the Untitled costume, you see that now it's actually manageable. Make it even 10%. Oh yeah, that looks a lot better. Okay, you can hide it completely. If it's gone, you can show it back. You can put it to the front. That's just in case you have multiple sprites, so you can say what shows up, what doesn't. This is interesting. You can play sound. Okay, and as an example of that, we can play a note. I can play different notes. So let's try note 80. Okay, let's try note 40. Actually, the numbers have to do with the MIDI sequencing standard. You don't have to know MIDI for this. You can actually just experiment with these. Uh, those of your students who have some kind of a musical bent might be interested in knowing that the notes are separated by a half note. Okay, so 40 is something, right? Doesn't matter what it is. We'll do 41. We'll do 42. And this way, I can actually build a scale. Of course, the scale will go 40, 42, 44, 45, simply because you got a couple of whole notes and then a half note. But that's something that students who like music may be interested in doing. So you could, for example, write a program that plays a scale or play something more interesting. If you have multiple sprites, then you can now do like a choral composition. So one sprite can be playing a C, while another one is playing an E. Um, and you can do a whole arrangement for 4 voices or 8 voices or whatever you want. We played with the pen already, so I won't show you much of this. I'll actually just ask you to experiment. Control, there's a lot here. We did when the flag is clicked. You can do other things like when I'm clicked, which means when the avatar, or rather the sprite is clicked. You can also broadcast a message to everybody. This might sound familiar, right? You can broadcast a message to and wait, which becomes synchronous as opposed to asynchronous, which fire and forget. And right here, you say when I receive any message or a specific message, just this one, then here's what I need to do. Again, those should be somewhat familiar. Okay. Don't worry about warp. Okay. If you run into that, I'll be very impressed. But here are some interesting things. Wait 1 second. Wait until something interesting happens. Do these commands forever. And remember, you just drag commands into this little hook there. Do them 10 times. Repeat until, and we'll do some conditions later. And then here is an if statement. And an if statement lets me say, if some condition happens, then do the following. Otherwise, there's the else. Do something else. Okay. You can, of course, stop all the sprites, some of the sprites. Don't worry about these yet. Okay. You know, they're little fancier. And these ones you might be interested in. You can create a clone of yourself. And you can also have rules that tell you, hey, if I start off as a clone, then here's what I want to do. That way they behave differently than the basic ones. Okay. Sensing might be interesting. I can say, for example, am I touching the mouse pointer, the edge, and the pen? Am I touching a particular color? Okay. I clicked on it, so it tells me, nope, you're not touching that color. I can click on this one, and it says, nope, you're not touching the edge. Okay. I can ask for something like, what's your name? And now let me type in an answer. Okay. I could actually use that and then say, hello, Ruben. By the way, I just said answer and it showed me that. I can click on that and then it'll show me there forever. That's useful when you're debugging. Pretty much that's it. Okay. I can check, is the mouse currently down or not? Is this key being pressed, etc. I can even check what is my distance to, well, here's to the mouse pointer, but it could be to anything. It could be to another sprite, for example. Lots of things that you can do. You can even go to a website, although why would you? Turbo mode, you can experiment with that if you want. This snap was originally intended, or to say Scratch was originally intended for animations, and that meant that they throttled the agents so that it was more synchronized. If you don't want that, you set turbo mode to false, and it'll go a lot faster. On the other hand, you run into problems like what I did with the square, where it just does it and you can't see what's happening. Okay, operators. This let me do things like arithmetic. Here's an addition. Here's a subtraction, multiplication, rounding, square roots. If you click on this, you can see some of the other functions that you can call, like sine, cosine, tangent, etc. You can compare things. You can say this and that, this or that, not this, etc. You can join words. That just creates one word called hello world. You can split them up. Okay, so hello dash world, split it by a dash. You can do all sorts of things, which I will, again, let you experiment with.